Geometry Standard 9. We're going to look at analyzing transformations for your last geometry standard in 8th grade. Our learning target is just going to be, it's not an actual learning target, but I'm just going to share with you some basic informations about transformations so that when we talk about transformations throughout the standard, you kind of have a good idea of what we're looking at. So we're just going to start with some vocabulary words to start with. And so if you look at our first sentence here, it says to transform, and hence the reason why they're called transformation, because the word transform is in there. To transform a shape means to change it. In general, we can change the size, location, and direction that figure is facing. So transformation is just another word for changing. So we're going to change a shape of any kind of shape. It doesn't have to be a triangle. It could just be a image. It can be anything. And we're going to change the size, the location, and the direction that figure is facing. A couple words you'll hear me say a lot. The shape or figure before the transformation. So before you change it. And usually we say we move it. So before you change or transform that figure, we call that a pre-image, which makes sense because pre means before image, or sometimes you'll hear it as original. And we might just label that with an A. So that point that we're moving is just going to be labeled with an A. The new shape or the new figure after it's been transformed or moved, we call that just the image. So pre-image is before we move it. After we move it or transform it, it becomes the image or the new figure. And then we label it as, so that A that I talked about up here in the pre-image becomes A, and we pronounce that as A prime. That tells me I've taken a point or whatever we're looking at, and we've moved it, and now that new image is, or that image is now called A prime. There are four transformations that we're going to look at. The first one is translation. So what a translation looks like, if we look here, this is our pre-image because this is lettered A. So we have a pre-image. And then, of course, this is our image because that's A prime. So our pre-image was what we call translated down to here. So this would be your translation. It just slides. That's a key word that you'll hear me say a lot. It slides down onto this quadrant. So it's in quadrant 1, and then it slides down into quadrant 3 here. Another type of transformation is called reflection. This is probably one of the ones that you're probably most familiar with. You look at your reflection all the time in the mirror. If we notice, this is B, so this is our pre-image. And then it was reflected over this line of symmetry, or known as the line of reflection, and then this is your pre-image. So just think about a mirror image. Keywords, flip, you'll hear me say, or mirror image. So we've gone over 2 of the 4. We have a translation, a reflection. Now we're going to look at what we know as the rotation. And again, this is one that wouldn't surprise me if you're very familiar with. So we're going to look, this one's C, this is C prime, so this one is our pre-image, smiley face guy, and this is our image. So this was rotated from here, which is quadrant 3, up to quadrant 2. And the words you might hear me say is turn. And the last type is what we know as dilation. So look, that's D, so that's your pre-image down at the bottom here. Sorry. And this is your image. that was changed. And the words you'll hear me say when we talk about dilation is enlargement, because if you notice, this one has been reduced. So either that you dilate it larger or you dilate it smaller. So we call it enlargement, or to enlarge, or you'll hear me say reduce. So again, 4 transformations that we will be studying in 8th grade math: the translation, the slide, the reflection, the flip, the rotation, the turn, or the dilation is to enlarge or reduce. And we're going to take, as we go through this, we're going to do all the translation information for learning target number 1 and 2, and then we'll go to reflection, and then we'll go to rotation, and then we'll finally end up in dilation. So just to get you thinking about real world, where do you see these things in real world? So I'm just going to put down one list. Please add to it if you want. If you think about conveyor belts, I think about, an Amazon package. You sometimes see those commercials, and they put the box on the conveyor belt, and the box goes up to maybe the label printing machine, and it prints a label, and it just continues on. So that's a conveyor belt. You're sliding that object. It's just moving through a slide. Another one, a reflection. I kind of already talked about the mirror. So another one I think about is if you take an image near a body of water, on a body of water, you would notice that you're going to see that image reflect down into that water. Rotation, probably the simplest one that you probably see all the time, especially now that you're really excited about driving, are wheels. I mean, you just look at any wheel as our car as it's traveling by, it's rotating all the time. And dilation, I don't know if you've ever had your pupils dilated, or your pupils dilate when you go into a dark room, and then if you go into a bright room. So dilation would just be the enlargement, which is when you're in a dark room, so you bring more light in. Or if you are in a really sunny, or you're outside and it's really bright, then your pupils reduce, because we won't want to put as much light into your eyes. A couple more vocab words here: congruency and orientation. So a transformation that preserves congruency, that's the key word, preserves the same shape, keeps the same size and shape of a figure, and it's called to have a rigid transformation. So the key here is that I'll talk a lot about is the idea of congruency. And when a shape is congruent, it doesn't matter if I've turned it, or I've reflected it, or if I rotated it, or if I've translated it, or any of those words that I'll use to talk about transformations. If it keeps the same size and the same shape, no matter how it's been moved, we know that as being congruent. One thing that we look at is orientation. And another word, if you don't like the word orientation, is I would say positioning or position. So the position the shape is in, or the position, here in a second, we're talking about vertices. So the first one we're going to talk about is the orientation, or just, I use the word position of the figure. So what position is the triangle in, or what position is the quadrilateral in? And it refers to whether or not the figure facing the same direction on the coordinate plane after the transformation. So is that position of the figure the same, or if it's changed, is what we'll look at here in a second. The other vocab word, again, orientation or position of the vertices. And when we look at the position of the vertices, we look at in which the order the vertices are labeled. So if they're labeled A, B, C, and they're going clockwise, and then you look at again and see A prime, B prime, C prime, and it's going counterclockwise, then we'd say the orientation of the vertices have changed. So let's look at examples here. So if we look at this figure ABC, this again is the pre-image. This over here is the image. And if I think about the 4 I just taught you, is it a slide? No, because the slide just, it's like a conveyor belt. It's just going to slide over, and this one didn't just slide over. Did it turn? No, it didn't turn. It didn't dilate, it didn't get bigger or reduce or enlarge. So the only thing left is to reflect. So if you think about like a reflection line right there, that flipped over that reflection line. So we're going to write reflection here at the top. Size, the same. I mean, the size and the shape of this triangle are the same. Or I like to use the word congruent. So same size and same shape. The origin of the figure or the position of the figure, well, it's facing opposite way. So if you look at the pre-image and then you look at the image, they're totally facing opposite ways. So that has changed. And then it asks, how about the orientation of the vertices or the position of the vertices? Well, I just kind of draw arrows to help me out. So A to B, B to C, C back to A, that's clockwise. Then if I go A prime to B prime, and B prime to C prime and C prime back to A prime, you'll notice we're going counter. So the origin or the position of the vertices have changed. Okay, next one. We have ABC, we have A prime, B prime, C prime. We know it's not reflection, we already did that. We know it's not rotating, it's not turned. And we know it's not dilation because it's not an enlargement or a reduction. So the only thing left is a slide or a translation. You can see that conveyor belt going down. So we're going to write translation here. And then we're going to walk through our questions. So has the size changed or is it the same? So changed or stayed the same? Well, it's definitely the same. Same shape, same size, same everything. So we can call that congruent. Orientation of the figure, is it facing a different way? No, it's facing the exact same way. You just slid it over. So that is the same. And then remember the orientation or the position of the vertices. I like to make the arrows. That looks like it's clockwise. A prime to B prime to C prime. That is also clockwise. So everything stays the same when you translate. A couple more here. We have ABC. Ooh, and A prime, B prime, C prime got smaller. So that one's a fast one to know. That has to be dilation. So the size definitely changed. Hence, that's what dilation does. It either enlarges it or it reduces it. So the size has changed. And we call that, and we should know this word because we just used it in our last standard, similar. So dilations make similar, proportional. Remember, the angles are exactly the same size. The angle sizes don't change, but the corresponding side lengths are proportional. So I have no idea what the proportion is here. Maybe it's 2/3 the size of it was. The orientation of the figure, is it facing the same way? Yep. You just dilated it down. So that doesn't change the orientation or the position of the figure. A to B, B to C, C to A, clockwise, A prime to B prime, P prime to C prime, C prime to A prime, exact clockwise again, so nothing changed there. Just a enlargement or a reduction. In this case, it was a reduction. And the last one, not hard to guess, it's the only one left. It must be the rotation. So the turn. So the turn, if you look at the size of this triangle, they're exactly the same size. So they stay congruent. Orientation of the figure definitely changes because that's what the point of it rotates, so it's going to change. And our vertices, again, this is clockwise. We'll check A prime to B prime, B prime to C prime, C prime to A prime. Woo, still clockwise, so we have it the same. So hopefully that helped you. Now you can look at your individual practice and try to do some of these on your own now that I've explained to you the basics of transformations.